Oh, hey guys, Mr. Walker here. So you'll never guess what happened on the way to school this morning. I was getting ready to sell my cow Betsy at the farmers market, and I came across this guy, and he was selling magic beans, right? So he ended up taking a trade, and he traded me my cow. I gave him my cow. He gave me some magic beans here. So super excited. It's been a while since I've had some magic beans of my own, so I'm super stoked to have some here today. So. The cool thing about this is he sold me a whole kilogram of magic beans. These are some good-sized beans, and I'm sure they have a lot of magic in them. I'm kind of a magic bean connoisseur myself, so awesome, right? So good stuff happening today. So I just want to place these beans on the scale here just to make sure that I got my money's worth. Oh, and perfect. Look at that. Look at my scale. I know it's kind of hard to see in the light there, but I have a kilogram, right? It's measuring in kilograms, if you guys can see that. There we go, measuring in kilograms. So yeah, this whole bag here is worth a kilogram. It weighs a kilogram, which is super awesome. So let me let's take a look at here. Let's open this up a little bit. And so it looks like I have about 10 beans in here. And the guy told me that they all weigh the same. So if I have 10 of these magical beans and the whole bag weighs 1 kilogram, let's see if we can figure out what each bean is going to weigh. So Let's do that today. And actually, that's perfect because this goes right along with our math goal for today, which is using metric measurements to model the decomposition or the breaking apart of whole numbers into tenths. So this is going to work out great. Let me grab something to write on here and something to write with. Why don't you guys get the same? Get yourself something to write on, something to write with. And we're going to go ahead and map this out a little bit and see if we can use what we know about fractions, use what we know about tape diagrams and measurement and all that kind of stuff to help me figure out how much my beans weigh so we can get to work here. All right, once you have those things and you're ready to work with me, go ahead and click continue and we'll keep going. All right, so here's how I'm going to model this out here. So we know that my bag, I'm just going to draw this shape here to represent my kilogram, my bag of magic beans. So we know that 1 bag is equal to 1 kilogram, right? All right, cool, that's easy enough. But I have 10 beans in here, and they're all the same size, right? The guy told me they're all the same size. So let me go ahead and divide this up into 10 beans. Okay, so even though my squares aren't all exactly the same size, I got 10 of them in here, so we're okay with that. So I have 10 in here. So what is each one of these, thinking fraction-wise, what is each one of these boxes going to represent? Tenth, right? So that means each one of these beans, each one of my magic beans, is going to weigh 1/10. So I'm going to go ahead and write that here. 1/10 of a kilogram. Okay? Because it's not the whole kilogram, it just weighs 1/10 of it. Since they're all the same size, there's 10 of them in there. Each bean is going to weigh 1/10. And I know this bean might look like paper wrapped in tape, but I assure you that this is one of the finest magical beans you can find. In fact, these are really rare ones, hard to get a hold of, and they grow really, really super fast. So that's pretty cool there. So let me go ahead and put this back in the. Oh, I dropped it. Where did? I'll find it later. I don't have time for this. We got more beans in there we can work with. Okay, so anyway, we have each bean is equal to 1/10 of a kilogram, right? Okay, so if I had 2 magical beans, right? If I had 2, this is a nice pink color. This one means it's nice and ripe. If I had 2 beans, that would be 2/10. If I had 3 beans, that would be 3/10, so on and so forth. And all 10 of those beans together in the bag would be 10/10 or 1 kilogram, right? All right, so we could start to think of it in that way, and we know fractions, and we've dealt with that before. That's not really a hard concept to deal with. So I'm going to expand upon this a little bit, expand upon what we have here with our tape diagram, and I'm going to go ahead and draw a number line down here. On this number line, I'm going to go from 0 to 1, okay, which would be the same as 10/10, right? We kind of said that. 10/10, so 0 to 1 is 10/10. And I'm going to divide this number up into tenths. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10, okay? I divided it up into tenths. And what I'm going to do first is I'm going to weigh one of these beans. So I'm going to put this scale back out here. Turn it on. Make sure we're zeroed out. And I'm going to put one of these magic beans on here. So let's see what we come up with. Ah, cool, look at that. So we have a tenth. We're going to ignore the thousandths place for now, and we're going to talk about that in a second. And I have a tenth. What do you notice about that that's different from what we wrote over here? Right, exactly. This is called a decimal. And this number, this tenth, is written in decimal form. So I'm going to go ahead and write that here. This would be 1/10 in fractional form. And in decimal form, it would be 0.1. 0, then a decimal, and then 1. But we read it as 1/10. We don't say 0.1, we say 1/10 because that's the place value it's in. Oh, so what is decimal place value, you ask? Great question. All right, so let's put up a diagram here. All right, so place value, you know what place value is. We know we have the ones, the tens, the hundreds, the thousands, so on and so forth. Decimal place value is everything to the right of our ones. So this is when we're making smaller numbers. This is when we're making fractions, okay? And another way we can represent those fractions, those parts of a whole, is through decimals. So in our decimal place value, we have tenths first. We don't have oneths, okay? We have tenths, and you can hear that tenths. It has that TH at the end of it, okay? That distinguishes it from our tens, which are 10 whole numbers in the other side of the place value chart. So we have tenths, we have hundredths, we have thousands. Each one of these is going to be a smaller and smaller piece of the whole, okay? And let's step away for a second. I want to actually do a little bit of a refresher, or dive a little bit deeper into what decimals are. And we're going to check out a couple of other videos that are going to help us to do that, okay? So check out those real quick. You can either click on the link or hopefully stay tuned and those videos will play. But we'll check out those and then we'll come back and we'll talk a little bit more about my magic beans. All right, awesome. So we're getting some good sense of what decimals are. So let's work with them a little bit here and relate them to what we already know about fractions and measuring these magic beans that I bought. So if I kept going along this number line, right, I would have 2/10, and I would have 3/10, 4/10, all the way up to 9/10, right? And we could represent this using decimals in much of the same way. We would just say our 0.2, we would use that decimal point, 0.2. We don't necessarily need to put the 0 there, but it kind of just helps to frame that number a little bit so we can see it a little clearer. So we would have 2/10, 3/10, 4/10, on and on and on, the same way using decimals. We're just basically two different ways to represent that part of a whole. We could say 4 out of 10 pieces, 4/10. We could say 4 out of 10 pieces, 4/10. It's the same thing. So why don't you guys finish filling out your number lines, or draw a number line like mine, just so we have an idea of what this is, and we can refer back to it if we need to. All right, so right now, with the beans that I have, my magic beans in my magic bean bag, I have 9/10 in this bag because I have one of the beans in my hand. If I have this 9/10 plus this 1/10, that's going to give me 10/10, which will be the same as 1 kilogram, exactly, 1 kilogram. So I can compose and decompose one whole in a bunch of different ways. I could think of it as 10/10. I could think of it as 2/10 plus 8/10. I could think of it as 5/10 plus 5/10 equals one whole. They're all like the same thing we're thinking about with fractions. We could do the same thing with the decimals, okay? All right, so that's kind of the main thing that we're kind of getting at here. We're kind of seeing that fractions, decimals are the same thing, and we can break them apart and we can add them together much in the same way as we did, as we've done before, okay? All right, guys, I don't know if you've noticed or not, but there's the bean that I dropped before. It's already growing and it's sprouted up behind me, and we got ourselves a beanstalk to climb. So let's do this. Let's go exploring. I've never heard anything bad that happens when you climb a magical beanstalk that just grew out of the ground into the clouds. So let's check it out. Let's see what happens. All right, let me do a little stretches first. All right, here we go. All right, guys, so we're kind of wandering around in a new place here, a little wary. I've heard some stories before of maybe like giants and stuff like that, so it's probably not a bad idea to protect ourselves. And I just so happen to have brought my meter stick with me because I don't leave home without it, right? You never know when you're going to need a meter stick to protect yourself against giants or mythical creatures or anything like that. So we have this meter stick here, right? And I can't really fit the whole, there we go. Okay, so we have this meter stick. And as before, like we did with our 1 kilogram of magic beans, we separated out each bean and weighed it. And we saw that each bean was a tenth of that kilogram, right? A tenth of that total, one whole. And then we talked about decimals and how decimals are like fractions and they're part of something, right? Well, I have this meter stick here, and I know out there, you probably want some protection too as we're journeying through here. So I could break apart this meter stick, right? And there's about, let's see, about 10 of you out there right now. So if I were to break this one whole meter into 10 pieces, each of you would get how much? You'd get a tenth, right? You'd each get a tenth. So let me go ahead and let me see if I can. I don't know if that's gonna work so well, but just kind of use your imagination for a second. You know, on second thought, let's do this. Let's put up a meter stick here, and we can divide it into tenths, okay? And we can talk about the different combinations that we can make here. If I broke it into tenths, you know, I could give 6 of you a tenth, and then these 4 a tenth, and I had given you all of those tenths, right? I'd have 10 tenths there. So you talk about, like, you know, our decimals, we can add much in the same way we had fractions. We can combine them, we can put them together. A lot of the same things are going to happen here. Or let's say I gave 9 of you a tenth, and then me and my friend here had to do rock, paper, scissors over the other one. So it'd be 9 tenths, there would be 1 more tenth left, and then somebody would be with that one, but whatever. So you get the idea, those different combinations we can use to make one whole using tenths, okay? All right, guys, so we got our meter stick, we got protection as we're journeying around up here, but I don't know about you, I'm getting a little bit hungry. We've been doing all this climbing and all this walking around and all this math. I'm getting a little hungry, but all I have to eat is like a fun-sized Milky Way, so we're gonna have to ration it between the 10 of us. So I have a ruler here, and that Milky Way is only gonna be it's only 1 centimeter, like it's tiny, right? It's the fun-sized ones. So I could split that up between the 10 of us, split that into tenths, and each one of you would get 1/10 of a centimeter, okay? So there's 10 of us, including me. So I could say that 1 centimeter is equal to 10 tenths of a centimeter. And I'm going to hand out 9 of those tenths, right, to the 9 of you out there. I'm going to keep 1 for myself because, you know, it's going to fill me up, right? So if I did that, I would be giving out 9 tenths of the centimeter of chocolate, of my Milky Way. So I could write that as 9 tenths, which is also equal to, in decimal form, 9 tenths this way, right? 0.9 tenths. And if I had those 9 tenths and I added in my 1/10 that I had, we would get 10 tenths and we'd be back at 1 whole centimeter, okay? So the reason for doing all of this today, besides being able to plant some magic beans and climb a beanstalk and investigate a creative world up here, is for us to just start to understand different ways that numbers can be broken down in different forms that numbers can be written in. So we have our 1/10 as a fraction, we have our 1/10 as a decimal, and we can combine those tenths in different ways to be able to make one whole and different things like that. So you guys are going to practice with this some more today. I know we've watched a lot of different videos, we've experienced a lot of different things, but hopefully this is enough to get our brain working, get our brain started on what we've been doing here. So as always, please reach out if you have any questions, comments, or concerns. I appreciate all the hard work you guys do on a daily basis, and I'm excited to begin exploring more, not only of this realm up here, but also about decimals and what we can do with decimals. So thank you guys for watching, and we'll talk to you soon.